Hey everyone, welcome back to my channel Tech with Megha. And in today's video, we are going to talk about GitOps. We'll understand what GitOps is, what is the GitOps workflow, what are the famous GitOps tools that are available, and understand the concept. So let's begin the video. So let us understand what GitOps is. GitOps is a way to perform continuous delivery process by leveraging Git as single source of truth. GitOps is a set of best practices where the entire code delivery process is controlled via Git, including infrastructure and application as code, and automation to complete the updates and rollback. So, here, infrastructure as code examples are like Ansible and Terraforms, where you declare your code in the form of YAML. Let us go through the GitOps principle. So, the first principle is declarative. It states as a system managed by GitOps must have its desired state expressed declarative. So here, desired state is what? Is a description of how the system should operate. So we declare it in the form of YAML. So whatever description or whatever you want to implement will be declared in the form of YAML. And that is what we call as infrastructure as code. So you may be using Ansible or Terraform for doing that. Next principle states that versioned and immutable. Desired state is stored in a way that enforces immutability, versioning, and retains a complete version history. So here, whatever desired state you have mentioned in the form of YAML using Ansible or Terraform or any infrastructure as code tool, that desired state must be version and immutable. So, in order to do that, you will store it in your Git repository or code repository. So, some of the examples are like GitHub or GitLab or Bitbucket. You're not only storing the code but also versioning it. So, in such a way that whatever changes are done, you will keep a track of it. You will have an history that okay, these are the changes that were implemented by so and so person. These were the changes that was implemented at this time. So that is why all your desired state must be version and immutable is one of the GitOps principle. The next principle states that pulled automatically. Software agents automatically pulls the desired state declaration from source. So, what happens here is that we have a GitOps agent that will be sitting in the Kubernetes cluster. So, in short, we can say that a GitOps agent will be deployed in your Kubernetes cluster, which will be constantly checking the source of truth. And Git is the source of truth here. So, mostly, like in our software delivery, we have pushed mechanism and then we have pull mechanism. So in GitOps, the pull mechanism, what it means that the GitOps agent that has been deployed in your Kubernetes cluster will constantly, or you can say that automatically pulls the desired state. So your desired state is what that whatever you have declared as a code or your manifest files in your Git repository will have like constantly will be checked by the GitOps agent. The next principle states that continuously reconcile. So, software agent, or you can say the GitOps agent, continuously observes the actual system state and attempts to apply the desired state, which is like you can say your actual state should be equal to the desired state. So, the agent that has been running in your Kubernetes cluster, it will constantly be checking your Git repository and trying to see that trying to make your actual state, or you can say the live environment should be equal to the actual state. In short, we can say that whatever you have declared in the code or in the manifest YAML files should be exactly implemented in your environment, or you can say in should be deployed as an application in your cluster. Say for example, you have encountered some issue and you ask some DevOps engineer, architect, developer, anyone, so that someone will come and make those changes and bring back your environment up and running, and you will be happy. Okay, fine, my environment is up and running now, there is no issue. So what happened here is that someone is having a direct access to the Kubernetes cluster, and that someone is making the changes by running kubectl apply command directly into your cluster. So in this case, we do not know the existence of the changes that was applied to your cluster. So in this case, if the same issue occurs again, we won't be knowing, or we won't be having a track of it. Take an example, other one. If someone makes any changes in your code, or he made some changes, or he updated the code, and then he pushed it, and then he pushed his changes in the code repository, and he deployed the application, and then he logs off, and goes back to home. But for some reason, whatever changes that person or someone has done, it has crashed the environment, and the environment is completely down. So in such cases, we won't be knowing, or we won't be having any existence of what had happened. So the next person who logs in will be confused, like why the environment is down, who has done the changes. So he will be constantly debugging the issue. This would take a lot of time. So continuously reconcile, what this GitOps principle does, that agent will be continuously looking, or it will be continuously checking the Git repository. So in this case, what happens is that the developers, or the person who is working on the project, will won't have direct access to the cluster, or they won't make direct changes to the cluster. In such cases, what happens? In that case, what happens is your Git becomes a single source of truth. So in this case, if any issue occurs in your environment, that means you need to directly go into your Git repository, check that file, and make those changes. This is what GitOps principles are all about. So now let us understand the GitOps workflow. Before understanding that, let me show you a simple software delivery process, how it works when GitOps is not implemented. So we'll be having a developer who will be writing the code, and then he would be pushing that code to the Git repository, that is your GitLab, GitHub, or Bitbucket. So once the code has been pushed to your Git repository, we will be having CI tools. So these CI tool will actually build, test your code. So some of the examples are like Jenkins, Travis CI, Circle CI, Harness, and there are plenty of CI tools that are available. So once the building and testing of your code is done, it will be packaged, and it will generate some jar files, the Docker images, or you can say the Helm charts. So these things will be stored in one of your storage repositories. So it may be JFrog Artifactory, where you can store the jar files, Docker images, and Helm chart. You have Docker Hub, where you can store your images, Docker images, right? So this entire process is termed as CI process. Then what happens is we actually deploy the application into the Kubernetes cluster by running the kubectl apply command. So this is termed as the CD process. In order to perform this CD process, we will be using some of the CD tools, such as Jenkins. Jenkins is also can be used as CI as well as CD tool, and we also have Harness, and there are plenty other tools. So this entire process is termed as CI and CD process. So here, uh, some points that you need to note here is that in this traditional software delivery process, what happens is that the cluster state is manually decided by the kubectl command. So the person, or you can say the someone person, will be having a direct access to the Kubernetes cluster, or the platform that deploys to this cluster will be having full access to the Kubernetes cluster, which is actually your main production environment. So this is what happens. Now let us see when GitOps is involved, or you can say when we make use of GitOps, what modification happens in this process. So let us see that. Okay, before going through the GitOps process, let me tell you about the best practice about the GitOps is that, as I said, we will be storing our code in the Git repository. So the best practice is to have two different repositories. One repository will be dedicated for your source code. The other repository will be dedicated for the configurations, like your manifest files, or you can say your chart, hem charts, and all these things. So this is the best, you can say one of the best practice that GitOps is actually all about. So now coming to the GitOps process, what happens is that the CI process will remain the same. So the developer will write the code, push it to your Git repository. CI tool will do the build and testing and push generate some jar files, or you can say Docker images, Helm charts, which will be stored in your JFrog or Docker Hub. So this process will be same, but the difference comes in the CD process. What happens is that in one of the principle I was talking about GitOps agent. So here the GitOps agent is been represented by one of the famous tool, GitOps tool, which is ArgoCD. So your GitOps agent will be installed in your Kubernetes cluster. Okay. And this GitOps agent will be constantly monitoring or constantly checking your Git repository. So this Git repository is the manifest YAML files or the Helm charts where the configuration repository can be considered. So it will be constantly checking, and if someone, say for example, if some person or a developer makes directly changes to the cluster by running the kubectl apply command, ArgoCD or the GitOps agent will get to know ki, hey, this is not what I wanted. This is something different. My actual state is not equal to the desired state. There is a mismatch that is happening. So then ArgoCD will try to bring your desired state back to the actual state. So this is what the beauty of GitOps principle is all about. So in this GitOps tool, ArgoCD, in the UI, you have option to directly merge your changes to your cluster, or else if someone makes direct changes to your cluster, we also have option to set an email notification ki, hey, if any change happens, and since Git is your single source of truth, if that doesn't match, some email notifications should be sent. So this is what GitOps is all about. So here what happens is that the point that you need to note here is that nobody will be having a direct access to the Kubernetes cluster, right? And this, which is a GitOps controller that is running inside the cluster, is constantly monitoring the Git repository. And as soon as there is a changes is been made, according to the configuration that we have set it, whether to directly merge your changes to your cluster, or we need to send an email notification about the changes that has done. So according to the configuration, your GitOps agent will work. So this is the beauty of GitOps agent. So here we can see that the security is not compromised. Some of the examples of the GitOps tools are like ArgoCD, Jenkins X, FluxCD, and there are many other tools. So these are the GitOps tools that are like mostly used, and that is what about GitOps principle, GitOps workflow. And thank you for watching my video, and I hope that this video will be very helpful for you. If you have any doubts or any questions, please do provide in the comment section and I'll try to answer as much as possible. Thank you for your time.